Hi there, this is the one sample chi-square test under SPSS as done by Fields.
Last two movies, we looked at some of the most basic inferential statistics, the ones where we analyzed one variable at a time. We did the proportion for a nominal variable with only two outcomes, that is, a dichotomous variable, and the mean for a scale variable. In both cases, we looked at both null hypothesis tests and in confidence intervals in the second case. In this movie, we'll expand things slightly by looking at how to do a hypothesis test for a nominal variable that has more than two categories, something like occupation or favorite sport or whatever. Although it's possible to do confidence intervals for the number of people in each category, it's complicated and not particularly helpful for most purposes. Instead, we'll just do a hypothesis test that looks at whether people are evenly distributed across the categories in the variable. The test statistic that we'll use is called the one-sample chi-square test in SPSS, also known as the goodness of fit test. And with SPSS's new automatic features, it's a very easy test to create and to interpret. We'll do this by coming up to Analyze and come down to Non-Parametric Tests, and we'll click One Sample. We're going to use the basic objective of automatically compare observed data to hypothesize. That's the one we will use in almost every situation. Fields means the variables that we're going to use. Now, these are the four variables in the data set that are marked as nominal or ordinal variables, and so they're appropriate for a chi-squared test. We did gender in the previous movie. I'm actually going to leave it here so you can see what the results look like when you have several different kinds of variables. And we have these others: income category, price for vehicle, and years with current employer. So these are ordinal variables. We'll go to settings very quickly, and there's nothing there that we really need to change. So we're just going to leave all of those how they are, and I'll press run. Here's our syntax that we're doing several one-sample tests on NP tests. That stands for non-parametric. And then here's our table here at the bottom. Now this is giving us the overall result. The first three comparisons are whether the categories are evenly distributed across however many there are in that particular variable. And so for those, we did what's called a one-sample chi-square test. And then we have a significance value of 0, 0, 0. Now, it's not exactly 0, but it's very small. And in each case, it tells us that we should reject the null hypothesis, or in other words, that the distribution of people in our sample data differs significantly from an even distribution of the same percentage of people in each category. Now, note again, this table is a special one. This is called a model viewer if you look over on the left. So if we come over and double click on it, we get a lot more information. So here's the same table we had right here, and you see that we can sort it in a lot of different ways. We don't need to right now. And we have a chart off to the right and a little more information about each test. So right now, this is giving us information about the first test, which is about income categories. Now, I want to make something clear really quickly. This is not a very good chart because it doesn't start at 0. And so it makes it look like there's an enormous change from the second group to this third group to the fourth. If you want to see how it should look, come over here where it says one sample test view, and instead click on categorical field information. That's the actual bar chart that starts at 0. So yes, there is a big difference. It's about 2 to 1 as you go from the second category to the third, but it's not this enormous change that we saw in the previous one. I'm going to go back by clicking on one sample test view. Now, the green bars represent the hypothesized value, and you notice they're the same all the way across. That's because we're doing the simplest version of the one sample chi-squared test, which says we should have the same number of people in each category. Then we have below this the table that gives us the actual statistics. 6,400 people total. We have a test statistic or a chi-squared value of 654. We have 3 degrees of freedom, and we have a asymptotic significance test or two-sided test with a value of less than 0.001. Again, there's going to be non-zero values in there somewhere, but this lets you know that it's highly significant. Now we can do the same thing for each of the other chi-square tests. If we just come over here and click on this one, we can do the same thing for a primary vehicle price category, where there is actually a lot more luxury cars than would have been expected. We can also do this one for years with current employer, where there's a lot more people who've been there for relatively short amounts of time than we would expect. And then actually, this is the binomial test that we saw in the first movie. And so the model viewer here gives us a really Nice arrangement with a lot of information about these various tests. The one sample chi-squared test is a quick and easy way to tell if your observations are distributed evenly across categories, although you can set the hypothesized values to something else if you want to. It also shows how important it can be to check whether the variation you see in your sample could reasonably be attributed to random, meaningless chance, or whether you might start to see something important and meaningful.
So that concludes the simple chi, or the singular chi test. This is for homework discussion categorical data chi-square, which is due tonight. I think this is what SPSS is looking for, so I thought I'd share it with you guys.